So these are where this is where we stopped last class. So we are able to utilize some key data. For example, we are able to deduct a secondary data from a database which we sourced from World Bank, where we got the GDP per capita and GDP growth of Ghanaian country, and we are able to see the trend of how it looks like. That the GDP per capita and GDP growth that we even measure were moving in similar trend. Also, we try another example, which is using grade of students, which is shown here, that we now use to calculate some of the basic calculation in terms of the summation, which we said that one is using the function sum for addition of all that is in this row. So that's when we click use this sum of what is in the row. And we also did that for the whole row by just double tapping the end, which make it across the end. Similarly, we also calculate the minimum and maximum, and we say for the minimum you use the MIN, while we say for the maximum you use MAX, maximum. That is just for that one. So in the larger frame, so we went to look into analysis that we could run with the Excel software, and I showed us the way we installed by going under the data. I think I've explained all this menu bar, the home, the insert, the draw, layout, formula, data. So from the data, that's when we're able to bring out our data analysis plugin, from which we are able to run descriptive analysis. And I said for descriptive analysis, this one is bringing the central tendency and other key value like minimum, maximum, and key variables that we use to describe that we use to describe our central tendency, which is the mean. So we have the mean, which is the average of the data being considered. So on the average level, like for example now, oh, for the mathematics subject here, the average score we can see that it's running for 69.7, which is the average score of all the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the 10 students that we consider here. And we can see the median, and you know what the median means in the real sense. Median means that when you arrange a number in ascending order or descending order, what is the number that fall in between. So that's what they mean by median. And we have the mode to be 67. The mode means that which number comes frequently, most frequently among other variables. That is that one about that one. So for the uh, standard so, so we've explained all these. I've explained the mean, which I say is the average of all the sum of data that we are dealing with. We have explained median, we've explained mode, standard deviation. I think I penned some of the information down here. Let me quickly use that one to explain this. Okay, so the standard deviation is the dispersion or spread of data sets around the mean, meaning that how your data varies around your mean. And don't forget that the mean that we depicted for this is what is 69.7. So and you can see how data deviate around this, which is 6.44. We also have the kurtosis, which is just used to show the diagrammatic explanation of how our data diverges away from. And if you have seen a relative data before, you'll have seen something like a bell shape like this that they used to draw and represent now. Though mostly I told us the last class that most of the things that you're using, you use other descriptive for explanation. For example, if you are using for research purpose, it's majorly your mean, which is your central tendency, your standard deviation, which is the dispersion around your mean, your minimum and your maximum. That's most thing. The only thing you can still use to relate is your standard error. Your standard error is um, how close your final mean value is closer to the right option. So it's on real value before people use that one. So majority people use the mean, standard deviation, minimum and maximum. And in descriptive, what we just mean by the word descriptive is that you are just saying the way you saw it. For example, now if I'm checking all the subjects that we have over here, you can see that when we check the mean value, the in mathematics is having 69.7, English is having 73.5, verbal 72.7, likewise other one. So I can inform from this place that way most of the students are majorly interested, invest or majorly interested in what? In English, quantitative and French. Why? Because they have highest maximum value, and we can also consider them from the maximum value that we have. Okay, from the mean value, which shows highest value now. So if we are relating it, we can depict that way. Many people don't see mathematics, from my own analogy of what is there. Many people don't see mathematics as is serious, or probably did not put more efficiency to math because it's giving us a lower mean value. So that is what you mean by descriptive, just depicting what you see under your chart. And that is that one about that one. Are we on good terms? So for example, now let's now still go ahead further and do another data analysis in regards to correlation analysis, to see how these students mathematics correlate with the English. Let's use the correction rate. Though we're supposed to use a data that is more, but I just want us to use this basic one to relate how things look like. So let's select our input data. What we want to correlate? We want to correlate all these subjects, how they correlate to each other, how does they affect each other. That's what we mean by correlate from the word correlation. The first row is labeled and we have our data in column. And with that one, I can simulate. I want it to be on this same sheet. I don't want it to be on new worksheet. So I can state my output range. Select my output range. I want it to be in this bracket. And I can press OK. So if you check what we have here, this is the subject. But now let's check the correlation of English against math. This is English correlation of English against math. Is this correlation of English against math? Let me make it yellow. So we can see that the correlation between English and math is very low, but it's a positive correlation, meaning that we increase in English, we increase also math, but the correlation is very low, meaning that there's possibility of not being happen. Because we have three categories of correlation. We have one running from 0.1 to 0.3, which is the low correlation. We have a 0.4 running to 0.6, which is medium correlation. You can see that this one is feasible, that the probability of it happening. And we have high correlation from 0.7 to 1. So, but this one now is showing all the correlation that we have here. You can see that way is very low. It's not showing any visibility of being happening. So, but now this one is just guess data. Let's use a real data that was downloaded from a database. Let's use this. So let me use one of these data. This is the agricultural forest and fishery value added per GDP value. Let me bring this data set into, let me create a new sheet. So this is GDP. I believe the data I'm showing now should not be very new to you the way I say I got it, because that is what we went to go and reflect on from the data from the World Bank data set. Is a secondary data. So now this is data on agricultural, forestry, and fishing value added percentage of GDP. So what we actually want to do with this is we want to see how this variable correlates from country. These are countries in sub-Saharan Africa, Botswana, Ethiopia, Equatorial Guinea. So we want to see how the value of this agricultural and forestry fishery value added from 1994 to 2022, how it correlates from each of these countries. So in doing that one, same way that we did the correlation the other time is what I will go for by just going to my data analysis, and we can click on the correlation. On correlation, I need to select input, so I will select all the data sets that I have here. And I will be selecting my output to be also here. So with that, I can click that. So when we check the correlation that we have here, the correlation of this value, do you see any place that is looking significant out of this? We have all of them low, but we have, okay, this is on year. Let's erase this year out of our discussion. So do we see any? This is Ethiopia and Botswana. This is significance one here. Okay, you're not seeing this thing. Like this also.
If not, you are charging there, but we don't have to use your charger and everything.
Yeah,
This one is negative.
I will explain why. Can you imagine? So this is the correlation data that we got from it. And if you check this correlation, the data set of agriculture, forestry, and fishery value added per GDP in Ethiopia is highly, or this is positively correlated to that of Botswana. But in this regard here, the Niger one is negatively correlated to Botswana, Ethiopia, and Mali. What negative correlation and positive correlation means that way? When you are talking of positive correlation, when one increases, the other one also increases. But when you are talking of negative correlation, when one increases, the other decreases. So that's what that one, the result. So either negative, either positive does not concern you. What it concerns you in your discussion is that way. If it's negative, when one increases, the other decreases, and vice versa. But when you are talking of positive correlation, meaning that both of them are moving in the same direction, is that when one is increasing, the other is increasing, or when one is decreasing, the other is also decreasing.
Sorry, how do we properly how do we verbally interpret?
There's no neuronal correlation.
How do we verbally interpret it?
The interpretation now with what you are seeing here, you don't need to. Number one, you look for those that are significant. Though when we get to regression, you get it more. Even under SPSS, you get this more, because if it's under SPSS, it will bring the significance level. But I noticed that on Excel, whenever you run the analysis, correlation analysis, it only bring out the correlation coefficient for you, and that is what we are seeing, the correlation coefficient. So it's not bringing the significance level that way significance to. You'll have seen some data that probably when they are explaining, they are saying it's significance to 0.05 something, SF clinic or something. what we just want to do, what you want to check the significance level and the direction. Whenever this is the correlation coefficient. So what we are checking is the direction and the correlation coefficient. And immediately you are seeing is now what you just want to check the same thing whenever you run correlation analysis that way. Whatever you see on the row is what will also be on the column. But depending on the variable that you are now correlating together. So for example now here what we are just doing that we are correlating one country to the other country. So we are now saying that for example here we have 0.78 plus, that is South Africa to Botswana. So this one is showing that South Africa is having positive correlation to Botswana.
So that means
Because
the higher it's increasing in South Africa, the higher it's
the highest
increasing
also be in
in Botswana.
Botswana. So definitely there is high increase of correlation. But when you check other one like this one, this 0.3 is showing that it's low, meaning that it's rare. It's not that it will not affect each other, but it's rare before it will happen because it's a low correlation coefficient. And but when I say that when we now have a negative, we already know what negative means. Either is significant or not significant or highly significant. But the negative means that it will be in opposite direction. So that is what that one explains. Do we get the gist? But let's try to. Okay, you want to say something?
The one that is like that, what's the significance?
Which one?
Of that number.
Once is when you are relating with the same variable, what do you expect it to become? When you are relating Botswana data with Botswana data, it will definitely be one now. Meaning that they will affect each other on a neutral level. So, for example, now, okay, I have not gotten to SPSS, but let me use something to explain SPSS over here.
Our head will scatter.
Your head will not scatter. I just wanted to see something. SPSS, alright. So let's go under the regression analysis. But that regression, okay. So when you get under regression, you can see we have the Y range and we have the X range. And it's not the Y range is now what will be your result like this that we have. What will be your result? Which is your Y? For example, now if you are checking the impact of economic barrier or hindrances on economic performance of one country. So you can see from here that we have the Y range and we have the X range, which means the X is our independent variable that we want to use to see the performance on this Y. And I was saying that, for example, when you are looking into how some of key variable affect the economic of one country, and the economic variable will not be your Y. Why other factors that you want to consider how they impact economic value of that country may not be what you put on next. For example, now listen, let's look at some of the data that we can use here. Let me pick from this data set that I have here. Let's look into the data set and pick something somewhere that we can use. Oh, I see window here. Okay, let's look at this data set from the country of country data set. Okay, let's look at this data set from let me see if Nigeria is having full data set here. Nigeria is not complete. Let me look for country. We're not near complete. Okay, let's use this Mali data set. Hope this thing is clear to you people. And it's not that I'm doing one abracadabra. Ó ti ń ṣe kí ni? Kí ló ń dàrú?
What we are doing now is the regression analysis.
It's regression that we want to do. Okay, this is the data. wait o, before I continue, let me be asking question lẹ́ẹ̀kan torí tí gbogbo yín sọ pé ó ń dàrú yìí, kí ló ń dàrú gangan? This is a data set that is already being cleaned that we got. This data set is for Nigeria country and it's showing the population growth, agricultural, forestry, we have GDP growth, we have GDP per capita, we have GNA. All these are economic factors. All these, even the GNI, we have the trade, we have the employment in agriculture, we have foreign direct investments, we have labor factor. All of them are all economic factors. And we also have social factors like life expectancy. We also have environment factor, which is CO2 and
What did they
agricultural and
determine?
life.
What did they determine?
That's what I'm waiting for him to see first.
All these
And what do the economic factor determine?
economic factors determine as well.
Like you say, these are the economic factors
Yes.
that determine what or on what.
All these categories now, all
Yes.
of these are related to economy. That's what I'm saying. We've
Okay,
not
okay.
analyzed what we want to do. All these things, population, agricultural, forestry value added are economic. GDP is economic. But anything that we talk of CO2 emission, which is carbon emission,
Environmental.
they are environmental issue. Agricultural methane emission is also environmental. Forestry, which is like the forestation that we used to encounter, are all environmental. So now we also have some hindrances here, like limitation to infrastructure which is an example that we have here, which is access to electricity, can be regarded as an hindrance to either the economy, social, or environmental. Because when there is low access to electricity, there might be increase in CO2 emission, which is environmental, due to the fact that people will be using probably coal for most of their production, which is releasing much of carbon dioxide. And we also have limited access to finance when there's no money for the business also. So what we now want to check now, we now want to see how these independent variable, which are the hindrances, these one that are with limitation that I mark red, how does it affect one of these, either the environmental like CO2, or how does it affect probably one of the economic, maybe the GDP growth. So what we do now? Going to data analysis, regression. My why is that I want to see how these hindrances affect my environmental, which is CO2 emission. So under my why, I will only select that CO2 emission last. I'll check it back. Label is in the first row. I will input my x, which my x is this family, depending on which one you want to consider. Your x may be, because your equation for regression is y equals to x1 a1 plus x2 b2. That is a, b, that is we are referring to our coefficients of the x term, which your x in this case is access to electricity, your x2 is your domestic credit, your x3 is your individual. Don't worry, I will take time to explain. These are just simple statistics that I expect you guys should have known. Voila. So that is that one on the x. Let's say our output to be on the new range, on the new book regression. Regression line function return error. Please check the input range. So there is a problem of void within the input range. So where it's coming from is this. Let's close up this data set for us to have appropriate data set. So what is seen empty data set. The name is already taken. Try another one. And so this is the result for the regression analysis. So interpreting this result is another case exceptionally itself, because that is the problem I'm having with one of the clients I'm working with recently now. The lady does not want to pay for discussion of the result, and it's not giving me enough time to help. I was the one that do the analysis fine. but the lady does not is giving me short period of time for me to do this question, and me I have a heavy load on my neck, so I already told her that I can't pick up the discussion. I can only help her in explaining. But in most of the conversation that I've been having with her, it already shows to me that I have shallow knowledge in interpreting the result. Because if you are not the one that understood how analysis is being done, the person that analyzed for you will only send this result to you. It's your own problem to now go and relate with it that way. What is this one saying? What is this one saying from your result? Because from here now, listen, number one, at least on key level, on actual level, you first need the R square value, which here is showing high significance, which is 0.9, which shows the regression value is on high side, meaning that with this there is probability of your independent variable affecting your dependent variable. And another find you also related with is significance level, which this now if you interpret this one now, this one is telling that is 0.00000000, which is showing that is highly significant, because what you'll be checking for here when you want to discuss the results in a way is 0.05. Any number that is lower than this is significance, but any number that is greater than this is not significance. So for example now, like assuming here I'm seeing is 0.06, I would say that there is not correlation within this independent and dependent because it's higher than significance level. But in this case now, I'm seeing this as E. Whenever you see E minus 19, means that is 0.0000 until when you count 19 before these two, meaning that is very significant because it's lower than this. So when you don't know how the terminology works, it might be difficult. But that is for the general whole hindrances that we are considering. So now considering individual, like access to electricity, for example, on its own. When you are considering access to electricity on its own, you can see the P, you relate with the P value. You can see the P value here also is 0.000000 something before you get to 4. Meaning that this one is also significant. Access to electricity is significant on its own. Domestic, credit, private, you can see the how long it is also is significant on its own level. While the individual use of internet is also significant because of the zero level that you have, which is showing that the P value is lower than what is 0.05. So with this result now, listen, I can quickly predict that my access to electricity, domestic credit, which is access to finance, and individual use of internet, which is access to technology, automatically affect our CO2 emission. And in that regard of what is in there showing high significance, meaning that when there is high access to electricity, literally when you want to think about it, when there is high access to electricity, probably in renewable energy electricity, there will be reduction in CO2 emission because people will not be using combustion, all those charcoal or coal related. Like also in car combustion, people will not be using like petrol, gasoline, and the like. They will be using electric vehicle. So that's what that one implies. That is but probably next class we will explain this in details, because the essence of you as an analyst, it always used to help when you can also interpret the results. It's always easy to run analysis, especially when you've gotten your data cleanly very well. You just press button, oh my grades are. But it's always best when you can interpret what this individual result means, because that's what you use in discussion of the result. Are we on the same page? Olùyẹ tí mo kò ní jẹ́ kí nǹkan tí mo máa sọ máa sink sí mi orí mọ́. So let's stop there for tonight. Let me listen to question.